Hi, this is the story of our Moonbots team in OABB 4-H LEGO Robots. After 44 meetings and 400 plus kids and man-hours, we are finally close to the launch date. Enjoy our story.
The Google Lunar X Prize is a $30 million competition to safely land a robot on the surface of the moon. The robot needs to travel 500 meters and send images and data back to Earth. Like the Google Lunar X Prize, we need to travel on a simulated LEGO landscape, capture video, discover helium-3 and water ice, and make it back to our launch platform in under 3 minutes.
At the beginning of our project, our team discussed why we should go to the moon and what the challenges are with lunar exploration. New moon missions will extend our exploration of the moon so that we can better understand its origin and history. It will be important to find natural resources such as water, ice, and helium-3 rather than launching them into space because every pound of water launched into space requires many thousands of dollars to launch into orbit. The moon exploration is like a stepping stone to Mars or a launch pad to the universe. Let me introduce our team. Shannon worked on our website, our weekly blog, and the documentation of pictures and movies. Allison helped on the setup of the moon base, building and programming the robot. Stefan helped build the robot and the moon base. Besides that, he was the clown of the team. Ethan was programming and designing the robot. Robert, our resourceful team lead, with lots of design ideas and patience of filling his living room with a giant moonbot field. Henry, our engineering advisor and idea man. As part of our research, we took several field trips, including the JPL Learning Center, the Discovery Science Center, and the Jet Propulsion Laboratory in Pasadena. At JPL, we saw the assembly of the next Mars rover as well as the control room for many other robotic space missions. We learned why it is important to have autonomous robots. It takes 4 to 20 minutes for radio commands to reach Mars, which makes remote control impossible. There would be similar delays communicating with the moon robot. At the Discover Science Center, we learned about rocket propulsion and moon exploration.
During our robot design and research, we learned about gravity, friction, sensors, programming, photo paper with an interesting smell, sliding moonbot playing fields, and lots more. With all the challenges, we continuously look for new design concepts. Here are a few of the design ideas with different wheels, tracks, sensors, centers of gravity, claws, forks, and spears for collecting the water ice and helium-3.
Here is our final design. Not quite perfect, but we are confident that it will complete the mission objectives. The robot is using a LEGO NXT with 3 motors. 2 motors control the double-wheel tires. We use a skid steering with a differential drive. During the development, we tried several other steering methods, but this one was proved to be the best. The double-wheel configuration has enough friction to allow the robot to go over the crater and the center ridge. The 3rd motor moves the spears. The spears pick up the water ice and helium-3 gulls. With each water ice and helium-3 gulls, the center of gravity changes. The additional weights in the front compensate for the additional weights that allowed the robot to go back over the ridge. This ends our Moonbot adventure. Please enjoy a few more pictures and Allie's original music.